Hey guys, so in preparation for our quiz tomorrow, I said I'd post a video of me going over the concentration problems that I posted online yesterday. So to start, we'll go over the parts per million problems here. The first one says that helium gas, specifically 7.5 times 10 to the minus 3 grams of it, is dissolved in 1500 grams of water. Express this concentration in parts per million. And remembering that our parts per million equation is equal to mass of solute over mass of solution times 10 to the 6th power. Now in this case, mass of solute, 7.5 times 10 to the minus 3rd grams of helium, and solution, which is solute plus solvent, is 1500 plus 0.00075, so essentially 1500 grams of water. Divide that, multiply times 10 to the 6, and you'd get your answer in parts per million, which would be 7.5 you get 5 parts per million. And again, I chose 1e6 because e to the 6th is 10 to the 6th power. 1 times anything is itself, so 1e6 is 10 to the 6th power. The next one, I have 20 milligrams of mercury is dissolved in 1.9 times 10 to the 4th grams of water. What is the concentration in parts per million? So using the same equation as before, except here I have 20 milligrams of mercury and 1.9 times 10 to the 4th grams of water. Notice grams and milligrams don't cancel, so I can't do that. I need to convert milligrams to grams. In 20 milligrams to grams, I move the decimal 3 spots. You get 0.020 grams of mercury. I can then divide that by 1.9 times 10 to the 4th grams. Grams will cancel now. Of water. Multiply times 10 to the 6th. You get my answer, which is 1.05 parts per million. Now the third type of problem, again I'm using the same equation except I'm given a different set of knowns. I'm given parts per million, 35 parts per million, and a total mass of solution of 400 grams. It's asking me to find the amount of solute dissolved. So I have 35 parts per million equal to my unknown mass of solute divided by 400 grams of solution times 10 to the 6th. And since the mass of solution is in grams, I know that my solute will at start be in grams, realizing that I'll have to convert to milligrams later. So I divide each side by 10 to the 6th to cancel there. I would get I'm sorry, that's supposed to be 35. So 3.5 times 10 to the minus 5th is equal to my grams of solute over 400 grams. Multiply both sides by 400. So I got a little messy there. Which would give me 0.014 grams of solute. But I want it in milligrams, again remembering, so I have to convert by multiplying by 1,000 and moving the decimal 3 spots to the right to get 14 milligrams of solute as your final answer. So that's parts per million. So we'll move on to present composition next. So present by mass, again, WW or MM are the same thing from our notes. Of silver nitrate if 20 grams of solute or silver nitrate is dissolved in 135 grams of solution. The percent by mass, so WW, or you'll see it this way as well, is equal to mass of solute over mass of solution times 100%. So this is exactly like percent by mass. It looks exactly like parts per million, except it's multiplied times 100% instead of 10 to the 6th. So my mass of solute from the problem is 20 grams, and my mass of solution is 135 grams. And I divide that, multiply times 100% to give me 14.8%. The full label by mass, silver nitrate. Number 5, calculate the percent concentration by volume for methanol for 45 milliliters of methanol dissolved in 575 milliliters of solvent. So percent by volume is the same equation as mass, except instead of mass of solute in solution, it's volume. So I have volume of solute over volume of solution times 100%. And here I have 45 milliliters of methanol, or solute, and solution is solvent plus solute, so 575 plus 45, which is 620. Notice in 4 the solution mass was given to me, but in 5, even though it's volume, I had to add solvent and solute together to get the entire mass or volume of solution in this case. And multiply that times 100%, and I would get 7.3 roughly percent by volume methanol. Number 6 is probably the most challenging. Number 6 is probably the most challenging of the 3 problems. And it's showing the math needed to prepare 450 grams of 15.5% by mass acetic acid solution. So before we were dealing with just prepare any mass of solution. So we picked 100% equal to 100 grams, simply to have a 1-to-1 ratio. But here it wants me to have a total mass of 400 grams. And that means the entire solution, or 100% of the solution, would have a mass of 450 grams. That's a relationship I can use later in a proportion. But I'm trying to find what 15.5% of the mass would be, and that would be mass of acetic acid. I'll abbreviate that AA. So that information there can just be excuse me, manipulated into looking like a proportion. So I have 100%, 450 grams. The relationship between the whole and the whole will give me the percentage of acetic acid in grams. So cross multiply 450 times 15.5 divided by 100 gives me 69.75 grams of acetic acid. So that's the first part. I have 69.75 grams of acetic acid. But I also need to know how much solvent I'm using, so that would be 450 minus 69.75. The remaining mass would come from solvent, so 450 minus 69.75 is equal to 380.25. And that's grams of solvent, most likely water. So this information is what the answer is, but it's show the math, so all of this counts. This is the answer, that would be the point for the work, and then a point for labels as well. Moving on to molarity, that's our last type of concentration problem we'll look at today. And remembering a few things looking at these, that molarity, capital M, is equal to moles of solute per liter of solution. And that'll have a big impact on our next topic this week. And I also have the molar triangle, so molarity, moles, and liters, that can help me to find what I need to do later. So now let's look at number 7, now that we've kind of covered our background information. How many grams of silver chloride are in 350 milliliters of a 1.2 molar AgCl or silver chloride solution? So a couple things that I'm looking at here. I know also that I can convert back and forth from moles to grams using the molar mass ratio. So when it's asking me how many grams are in a molar solution, I know because of that molar I need to use molarity, but I can't get to grams directly, I have to go through moles. So if I cover up what I'm looking for, that'll tell me what I need to do. So I need to take molarity times liters, so 1.2 molar, times liters, and this is milliliters, so to convert I need to move the decimal 3 spots to the left to get 0.350 liters. That's equal to moles of silver chloride. So 1.2 times 0.350 gives me 0.42 moles silver chloride. But it asked me about grams of silver chloride, so again, using the molar mass conversion, I can go from 1 mole of a substance to its mass, silver having a mass of 107.87, adding that to the mass of chlorine, which is 35.45 from the periodic table, to give me roughly 143.3 grams. So then I multiply across, and I get roughly 60.2 grams of silver chloride. So keys here, recognizing that you can go from moles to grams, and that if it's asking for grams I have to get to moles first, and then using this triangle to figure out exactly what I need to do. So let's look at the other 3 molarity problems. And knowing this information, I'll reference it, but I'll probably go through it a little faster this time. So number 8 states how many grams of silver chloride are required to make 0.9 molar solution with a final volume of 0.350 milliliters. So again, it's asking me about grams, so I know I'm going to have to get through moles first. I'm given a molarity and a volume, so similar from before. I need to find moles, I cover that up. I get molarity times liters, so I get a molarity of 0.90 molar times 0.350 liters, again just moving the decimal 3 spots to the left to convert to liters, to give me 0.9 times 0.35 liters, which is 0.315 moles of silver chloride. And then again from before, 1 mole of silver chloride has a mass of 143.3 grams. Multiply that, I get 45.1 grams of silver chloride. That's my answer there. Now number 9 and 10 are, I am given a mass of a solute and a volume of solution and asked to calculate the molarity. And that's from the previous page, that directions, calculate the molarity. So I have 7.5 grams of sodium chloride, and I have 20.5 milliliters of solution. Calculating molarity, remember molarity is moles of solute per liter of solution, so I have to do some converting here. To get to moles first, I have to go through grams. Sodium chloride has a mass of 22.99. Add that to the mass of chlorine, which is 35.45, and you get roughly 58.4 grams per mole, which gives me, once I divide there, 0.128 moles of sodium chloride. So I have half of this equation here. I have 0.128 moles of solute. In liters of solution, I need to move the decimal 1, 2, 3 spots. I get 0.0205 liters. I take 0.128, divide it by 0.0205 liters, and I get a 6.2 molar solution, or thereabout. Again, as long as you're in the ballpark, you'll get credit. 10 is the same type of situation, given grams, so I need to know to calculate molarity, I need to be in moles, so I'll have to do a conversion there, as well as milliliters, so another conversion there as well. So 50 grams of lithium sulfate and 200 milliliters. Again, moving decimal 3 spots, I get 0.2 liters. And calculating the molar mass of lithium, I have 2 times 6.94, which is the mass of lithium. I have 2 lithiums, plus 1 sulfur, which is 32.07, plus 4 oxygens, which is roughly 16, to get a mass of 109.9, or 110 grams-ish. So 50 divided by 110 gives me 0.46 moles of lithium sulfate. And then I have my liters there, so I just divide the 2.46 moles divided by 0.2 liters. And I get a 2.3 molar lithium sulfate solution. That's a complete label. 6.2 molar would be acceptable for the test as well, though, as long as your answer is near and you put the molar there. That M counts as the label. So that's it. Again, if you have any questions, feel free to stop in, around 7:45. We'll have time tomorrow morning. Otherwise, ask a question, get to class early, ask a question before we start. Have a good night, guys. I'll see you tomorrow.